Hi, everyone. Thank you for coming to this session and having some time to learn about open source security. I work at Snyk. I'm a developer advocate at Snyk, where we build developer-friendly tools for open source developers, like probably every one of us in the room, to help us write and ship more secure code in a way that is integrated in our development workflows. I will talk more about open source security in general vulnerabilities, so it's not a Snyk-related talk. If you have any questions on that later, I'll be happy to take them. So a bit about me, I'm also a member of the Node Foundations, working with the security working group. So if you're getting all of those vulnerabilities from NPM audit, from Snyk, from anything else, that's probably some of those coming from the work that we're doing there. I am also involved in OWASP, which is a great initiative to help educate about open source security in terms of like web application security and stuff like that. I'm an active member of the NodeGoat project, so it's a vulnerable project that we can educate people about vulnerabilities and then fix them. I'm kind of a sucker for CLI tools, so I build those as well, and had the pleasure of writing a book about node security a couple of years back. So any questions about any stuff like this, I'm happy if you want to tweet me at Liran_tal, and we can just talk about it, or just find me here afterwards and we can talk just as well. So I want to start with, let's talk about open source, how amazing it is, and what a better way to just start off like this, right? Yes?
Of course.
Awesome. All right, so we're all using open source. It's pretty amazing. We're kind of contributing to it. Probably some of us here in this room. Others are kind of using it, reusing code, our friends and everyone else's. But what I actually want to take you on a path here is talking about your libraries or dependencies and what you're using. So probably for many of the projects that you have, now do this mental exercise and try right now to figure out which of these projects do you know all of those dependencies that you're using. So if we're talking here about JavaScript and Node, think about maybe Vue or maybe Express. And what dependencies does Express, for example, brings with it to the project? And do you know those dependencies? And do you know the maintainer that wrote those dependencies? And how often has anyone done on one of those dependencies a security audit? How often did someone do like the maintainer are they able to have security knowledge high enough for you to responsibly use this open source package? So as we ask ourselves these questions, we get into a point where we don't really know much about those dependencies. And actually those libraries and dependencies that we use, they're written by humans, by amazing people, but at the end of the day, they're just, they're strangers. We don't really know each other. We don't have a lot of information about those dependencies, about the libraries, about the maintainers writing them. And just to give you kind of, I'm going to pull you into this open source security and what exactly does it mean throughout this talk. And one of those is we ran the state of open source security report a few months back, where we asked maintainers, developers as well, but also maintainers, how are they interacting with security with regards to their open source projects. So this, for example, was a question about maintainers asking them how confident are they in their security knowledge, right? They could rate it from 1 to 10. And as you can see here from this survey, just a few months ago, 70% of the maintainers, they do not have a high level of security knowledge. So again, this is kind of tying up into open source security and responsibility of using open source. Another question that we asked is, in that survey was, how often do those maintainers audit their code bases? So think about using a code base, any library that you may think of. How often do maintainers go through, for example, a security audit? Are they doing security application testing? Are they doing code reviews, secure code reviews to actually vet each PR? Are they doing that or not? As you can see, what I highlighted is basically that a quarter of those maintainers do not audit at all, like any type of security for their projects. So you can, just counter dependencies in your package JSON manifest, 1, 2, 3, 4, that dependency did not go under any security audit. So, this goes a bit, a bit far with how we are, responsible to open source security. And what I also want to mention here is, for example, we're all using NPM. Some of us maybe are maintainers. And I chose to include here a tweet from February from Adam Baldwin, a security person behind NPM, right, working at NPM. And he shared the numbers where only 7% of basically maintainers, right, because that's who publishes things on NPM, on the repository itself, have 2FA enabled. Now, two-factor authentication is really, really important. I will talk about it like in 2 slides, but you can already understand like why that is so important to protect your account from being compromised, from someone else being able to publish malicious packages. He has, so this is like a 7% is a very low number. Luckily for us, he has a very positive next slide for that, where he shared just last month that this number is already up to 20-something%, maybe 23, 26. So that's very positive, but still, as a general security mindset for maintainers, for developers, this is still a low number of people who have enabled 2FA for something that is as precious as an NPM package that may be used by a lot of us in this ecosystem. So as we talk about issues, and vulnerabilities, we'll see a little bit later, but let's talk about maybe some malicious packages, right? Because not everything on NPM is, that amazing. There are some issues there that we need to figure out how to work around, and some threats that we need to figure out and understand what do they mean to us. So I listed 3 of them here, which are all a bit different from each other. Cross-env, I will start with that because that's kind of the thing that starts this timeline. Cross-env, like this, is a malicious package that actually bundles the original, the real cross-env package, which you write it with a dash between the cross and the env, which is a great package by Ken Dodds, allows you to manage your environment variables, so it has a use. But if you accidentally installed cross-env like this, you would have actually installed a malicious package that when you install it, would go ahead and read all of your environment variables and send them to someone else. Now, no one uses any secret or password in environment variables, right? Great, I see the faces. So imagine someone, right, like, a developer, junior, senior, whatever, just adding, accidentally, installing this package into your source code. It's actually bundling the real cross-env. It means that you will not see any different experience. Actually, getting the actual functionality. You merge it into production, it's going into master branch, it's deployed to production, then it's taking those environment variables, again, and everything that you have in them and sending them to someone else. Now, it's enough that this happens just once, and you've lost, a lot of precious information to someone else. This is a type of squatting attack. Moving on to ESLint scope. Everyone here, I guess, knows that. It's a very, ESLint in specific is a very prominent project in the ecosystem. ESLint scope is a package for it that, bundled within. And the ESLint scope specifically had a malicious version of it published to the NPM repository, where when it was installed, it did something similar to crossenv. It took all of your .npmrc, like all the tokens that you have inside, and if you're a maintainer, that token has a really, really, really important meaning, because that means that someone else is able to publish a package in your name if you didn't enable 2FA. So it would take all of those and send them to someone else. So again, another malicious package, which we didn't have to accidentally install. It would just get bundled if you are using that project. And it happened, as you probably ask, how does something like ESLint scope get a malicious version? Because an account of one of the maintainers was compromised. So they were using a weak password, did not have 2FA. Maybe their password was leaked through a data breach. Someone was able to hack through that and get this package published. The last one, FlatMapStream, is a malicious package that was used in EventStream, probably the most sophisticated and known attack that we've seen on the registry, on the ecosystem itself, that happened through something like a social engineering attack. So all of these malicious packages, if you think about it for a second, they are different ways of attacking end users, which is us, developers, at the end of the day, right? From having a typo squatting attack to a compromising account to a social engineering attack, all of which were able to be very successful in terms of impacting and actually compromising for different time frames, but actually compromising users. And this is developers. This is us at the end of the day. So let's take a use case where I'm talking about a serverless application written with a serverless framework. You don't have to read through it, but I can tell you that this is like 19 lines of code that I use to write a simple serverless function that fetches a file from a URL and uploads it to an S3 bucket. How many dependencies do I have? Are you able to see that? 2 of them, that's correct. I have AWS SDK, and then I have node fetch, which is a polyfill, and I am pulling in with those 2 dependencies 19 more, right? These are indirect dependencies that I'm pulling with me. But now, just again, as a mental exercise, think about it. I am building 19 lines of code worth of, a production-ready serverless application that does something very, very simple. But when I'm pushing this to production, I'm actually pushing, 200,000 lines of code throughout all of these direct and indirect dependencies that the application is now exposing, and this is an attack surface for someone else, where there may not be a problem in my code, but it may go through something else, and this is what I will show you later on in our live hacking session. So what would, I think, click for you, and this is what clicked for me as well when I saw it first, is as a developer, we are very, very focused on the code that we write, right, and not on the libraries that we use. So while a lot of time you may think that you're producing this, and sending this to production, the reality is that your code is actually just a very small part of it, and you're actually reusing a lot of, you're pushing code that is reusing a lot of other dependencies and pushing those to production. And this is okay to use open source. We are here because we want to make open source secure. But if you have this mindset, after this talk, this is the only thing that you're taking, having this mindset of, it's not just my code that could be vulnerable, it's everyone else's as well, and I don't know what's going on with, the rest of the libraries, then this is already like the first step of understanding how important this is. So some application security challenges that we're facing, right? Let's talk about it. So first of all, software delivery is sped up. Even if you are very security-minded, security-conscious, think about it. We are, as an organization, doing software development, we want to iterate very, very fast. We want to deliver stuff very fast to production, to our value to our users, etc. But then the question is, where does security fit into this model? Usually, like traditional application testing is, a pen test that is being done at, every quarter. This is like a really good use case, but usually it's not even that. But how does it go into like every commit that you're pushing in? So we need to think about it. Lack of security focus throughout the entire dev lifecycle. So think about the fact that not everyone is knowing how to handle security risk and application security. So it's not something that we study in computer sciences. Security is something that you usually just pick up as a developer, and we don't have this expertise. And the expertise is actually siloed. So if you look at it from an enterprise organization, if some of you work in that, think about the amount of developers that you have, and then the ratio for the amount of operations supporting them, and then the amount of security people to handle that. The ratio that was checked to kind of give you a good example is for every 100 developers, there are 10 operations and 1 security person. And this is like, again, a very, very good situation if it happens at all, right? Usually it's a lot worse. So throughout all of this, DevSecOps is something that tries to answer this problem, just as if DevOps is trying to figure out similar examples. And again, to give you more ideas of how open source security and libraries that we use daily for JavaScript, web front-end development is so ambiguous. Is, for example, as we tested something like 500,000 websites, we found that 77% of them have at least one vulnerable dependency, right? So that's at least, probably a website with a very outdated jQuery or Lodash or, something else that you're using in your code to build a website, and that's vulnerable. Another interesting fact about us as writing code is something we tested, this is from a couple of years ago, is as we look at vulnerabilities, like after they happen and after we discover them, if we can look at retrospectively back and say, from the point in time that this code was introduced, I wrote that, that vulnerable code, it was a bad, if, a bad sanitization, whatever, how long does it took until it was discovered, until someone found it? Do this mental exercise for a second and think about how long can it happen? What is the worst case, or in this case, what is the median, what is the average time? The answer to that is pretty overwhelming, right? It's 2.5 years as an average time for when a vulnerable code, like an insecure code, was added to a project until it was discovered. That's the time that a vulnerability lived in the code base throughout the project's lifecycle. All right, so with that, maybe let's do some live hacking and go through some real-world vulnerabilities. So I know for some of the people in the back, let's try to make sure that you're seeing things, and if not, just raise your hand and I'll take a look and to increase the font, etc. So what I'm going to show you is there's a to-do app over here. think you're not seeing the, oh, there we go. So there's an input here, but the projector is having a hard time showing it if I'm not over it. But basically, this is a very simple JavaScript application to do up, just for the exercise experiment. And what we're going to see here is some use of open source libraries and how they manifest as vulnerabilities. So I can go ahead and write hello Odessa. And I can go ahead and since this is using Markdown, I can go and use the Marked library. And just write Markdown. So I can do like this. And I have a link. And as you go through this experience, and maybe you want to go and try to add XSS into it, you might think, let's go through the classic case of adding just a script tag and trying to exploit it. The thing is that this library has the ability to sanitize this input that I'm giving it. The bad thing about it is that by default, this version of it is actually, you need to opt into security, so it's disabled by default. So for us, I actually enabled it to kind of make it more interesting, and we're still unable to hack it. So what I can do more is think about how JavaScript links can manifest. So I can go here and add JavaScript like that, right, and try to hack this. I'll make it a bit larger. And we're seeing that Marked was able to sanitize through it and figure it out. So far so good. Seems like things are working well. Except, what if we try to kind of go and, tweak the sanitization in how things are done? So maybe I could go and replace the colon. I can see how Marked, it's open source. I can go to the repository, look at the code, read it, and figure out how it's actually trying to sanitize and escape it. So maybe it's looking for JavaScript colon, and maybe I want to replace that. So I would do something like this, for example. And I could do the same here. So basically now I'm just representing a colon as the as the HTML entity for it. So which is this, right? And this is a way to kind of go ahead and trick any kind of sanitization. But things look like as if Marked was able to escape that as well. If we'd go to the code base, we'd actually see that it's actually trying, there's a regex that matches these kinds of strings, and it's smart enough to, whoever wrote it was a smart developer in terms of security awareness, to go ahead and try to figure out all of your escape hatches. The only problem here is that there's a connection between how the browser interprets stuff and what you send to it, right? All the stuff that you send to it. So in our case, the way to trick that is what would happen if I would put a valid JavaScript statement like this, or for example, we could put a document inside as well. And this goes just fine throughout Marked, because Marked has, doesn't cover this in the regex. But if I do this, what happens is the browser, it will go ahead and say, well, I think that this is a mistake, and you probably meant to add a semicolon here, so I will close it for you, as browsers usually do, and let this in. And when this happens, then now this becomes a valid JavaScript statement. So if I have something like that, this is now an XSS that we were able to inject through Marked, which is vulnerable to these kinds of attack, right? So at the end of the day, you could add, better sanitization in how Marked works, and this was the fix that was later on brought into the ecosystem. So Marked, just to give you a representation of how popular this is, right? Marked is a project with 2 million downloads a week. Okay, and they're already alternative because this is a pretty old project, but it still gets downloaded quite a lot. You can use it on the server side, you can use it on the front end to do this thing. So it's something that is pretty common. And when a vulnerability arises in a dependency that we are using, this is something that is important for us to figure out how to fix it and remediate it very quickly. So I want to show you another example of a vulnerability that can happen here. As I scan the project through Sneak before, and I'll show it later, but basically there's a couple of other vulnerabilities that we have here. Let's choose just one to proceed with the demo. So as I add a new text, let's look at how that shows. So when I add something, I'm gonna put that down so we can see it. So it's going to send this request to this create endpoint, a post request, to just add this, this item. So let's go ahead and try to do something with that as well. So for example, what we can do is like say, buy borscht in 5 minutes because I'm in Ukraine. And what will happen is there is logic in this to-do up, as would probably be would make sense, to translate those 5 minutes as a text, kind of like a DSL thing, into like 5M to represent it in a different way. What is doing that is a library in the code that is called humanize-ms, which is gets fair bit of downloads as well. Interestingly enough, humanize-ms is kind of just a small wrapper around MS, which is completely more popular. So if we were able to go ahead and check MS, that would be tens of millions of downloads. As that goes, I will open the code, and we can see what's going on there. So I have my routes here, and oh, there we go. I have this parse function, which uses HMS, which is the library that I showed you before. And you can see it's trying to parse what I'm giving it. So like, buy milk, buy borscht, whatever, buy something. It's a very simple, parsing in terms of what it's trying to do. Regexing it through it, and then, passing it to HMS to represent those, 5 minutes into 5M. That is just, displays maybe in a better way. But this is all that it does, right? Let's get that maximized. There we go. This is all that it does. MS is, fairly popular, and the thing is that MS, gets that, 5 minutes, and it tries to do regex to figure out what is the input and give you this representation of numbers basically of microseconds into it. How it does that? Of course, using regexes. So let's talk about regexes for a second. So regular expressions are basically state machines that are trying to evaluate, an input and a pattern and get into the end state of it. Specifically in V8 JavaScript, the engine is a non-deterministic finite automata, which means that it's going to go and try one by one each state until it reaches the end of it, the end of the input or the end state itself. And if you want to think about like what does that mean is think about a maze where you have a mouse, and the cheese at the end of it, and the mouse goes into all possible ways, retracts back, go again, retracts back, go again, until it reaches this end state. The thing is that in extreme situations, you could trigger the regex engine, which is computing compute resources bound, to go ahead and evaluate into an exponential time and require a lot of time for something that evaluates the regex. So what is kind of often is missed around developers is the fact that regexes are CPU bound. And if you have a vulnerable regex, that means that in Node.js or in JavaScript specifically, that's going to block the event loop, and then no other thing can be processed during that time. So this is what I'm going to try and get into with this demo of being able to try and do a denial of service to a regular expression, which what is happening with MS. So as we've seen, this network call, I'm going to go and send something here. Is this something that you can see?
Yes.
Okay. And I'm going to open monitoring a bit lower so you can see the CPU being used. So I'm going to send content is, let's make it short. So I'm using the HTTP tool. It's just a simple Python thing, and I'm going to be able to send that. And when I'm done, you can see the request going in. Right, and then buy milk in 5 minutes, that's okay, that's what we expected. But then I can go ahead and what if I was able to send a bigger number? What if it's not 5 minutes? What if it's increasingly a large amount of numbers to go ahead and parse? So what if I could use something like sequence like this. I can format the number 5, use a separator nothing and repeat that 1 time, that's great. Let's repeat that 10 times. Sorry, let's repeat that 10 times. And this is what I will try and feed into my my content that I will try and inject. So instead of this, I will go ahead and replace it with that. I like that you're using ICQ. It's big kudos for that. You can connect afterwards. I have a 6-digit number, so pretty old school. All right, so I'm going to go and send in 60K right, characters of 5 and see what happens. Amazingly enough, nothing. Right? It simply parsed it as infinity, which kind of makes sense. Like that's kind of what we would probably expect. So I'm now gonna fire up the htop tool. You're not seeing that to me. Let me do this here. We can switch to this in a second. So with htop, I'm gonna check what is my node process doing. And here, like, we can go and do something different. So as I told you, with regular expressions, we can go and trick the regex evaluator, the engine, into getting, if it's a vulnerable regex pattern, we can trick it into getting into an exponential time until it evaluates. So for me, it's enough to say, in this pattern, for example, I will not use the word minutes. I will just change that with mineta, because the regex pattern that the MS library is using behind the scene is trying to evaluate, something, some number minutes, or something, some number hours, etc. So it's not going to find the minutes, and it's going to go and what it does, it actually does a backtracking. So it's going to go and not find minutes, and then it's going to backtrack and 5 minutes, and then backtrack and 5 minute without the e, etc. until it's able to do that. But it's going to take it an exponential amount of time to do it. So as I do that, first of all, you can see that like the UI is not responsive anymore. If I go to htop, you can see that node is now consuming 100% of my CPU. No other requests are getting processed. And just a few seconds later, you can see everything getting back into shape, right? Everyone got that? Cool? All right, so this is an example of a regular expression denial of service, where it's not, I am not fond of writing regexes myself, but even if you don't try that yourself and you're using some library, that's also a bit vulnerable, and you can have these situations. So let's go through another vulnerability. So I have this about page, and it's called about new. So I'm a great front-end developer. It's a mobile-first device. Let me prove it to you. A mobile-first app. If I add desktop, it's a bit smaller. If I change it to mobile, it's a bit bigger. Yay, mobile first. So what would happen if you were able to go ahead and do something around this input? So for example, let's say, let me show you first what's happening here. So with the code itself, it's using Dust.js as the templating engine. And what it's trying to do is, have some logic. So if I'm giving it the device's desktop or mobile, it's going to draw different sizes of the font that you've just seen. The thing is, Dust.js is a templating engine that the way that it works is it's going to go and evaluate whatever input that I give it, because that's kind of how template engines work, right? So if I was able to inject somehow something into the condition here, I would be able to evaluate this on the server side. But it's not so easy to inject stuff, because Dust is a security-minded library, and it means that it has those escape HTML parts. So if I was able to try, if I wanted to try and escape it, with some strings, it would go ahead and convert them and encode them to something that is is not able to escape the context of what I'm trying to inject. So again, if we go to what's happening here, like what would I try to do? I would go and try to somehow escape, right, this logic to be able to add my own into this condition variable. So the first thing that comes to mind is maybe we can add, a quote, like kind of escape what's happening here with the quotes. But we're seeing that this is actually handled, and this is what we saw before. And if I would be trying to do something kind of near that area, then let's think about what's going on. This escaping, if you look at it for a second, if that's like big enough, this escaping function, it has a flaw. The flaw that it has is that it is only applying it if my type is a string. So what if I was able to send something that's not a string, but something else that would just pass through this, but still be a string at the end of the day because I need to pass it into evil? So this is where, for example, another kind of vulnerability / attack is made possible. Like what happens if I would represent this as an array with the bracket notation, and I would go ahead and try to send an array, a device array equals mobile. So this works because, if you do a toString to an array, you're going to get the first element. So this kind of works in terms of functionality. So it looks like nothing is broken. But if now it's an array and I'm trying to kind of inject something like the single quote again, I'm going to get this error from evil telling me that something is happening there. And this is where things get interesting. So using an attack like an HTTP parameter pollution, which means that I'm sending stuff sending like query string variables that the server may not know how to handle, I'm able to kind of manipulate the internal logic of things that's going on inside. So to show how this goes a bit further, where is our code base? There we go. So we can do something like this. And so far, so good. I sent a request. I got a reply back. I'm going to go and escape it. Sorry, I'm going to go and escape that as well as an illegal character. And I'm seeing that things are still working okay. And I'm adding a single quote, and things are now broken. Like you can see on the left side, the syntax error from my request. Now, how would you go and exploit that, right? So think about Node itself and how it works. Let's do an eval exercise. What's really happening there is something like this. Right, let's see. Yeah. So what's really happening is something like that. I'll make that a bit larger. I see that some people are having a hard time reading it. So it's evaluated true, of course. Obviously, that's what's happening. But then I can go ahead and try to make that's a value, right? So I can put an expression there and see what's going on. So I can do something like this. Console log 1, whatever that is, and subtracting it from something else, basically even nothing, I don't really care. And what happened is this is again an expression. So it's going to go and evaluate it. So it's actually running this function expression, console log, and I'm seeing that as 1. So it's as simple as simply running that, right? And let's see what's going to happen. Oh, I lost that one. Let me grab this again. Right, so at this point what happened is I actually executed console log 1 on the server side because that was what evaluated, because we escaped throughout all of this learning process about this vulnerability and been able to execute that. So if you think about it, like at the end of the day, what an attacker will do, of course, is not console log. I can go ahead and change that with a simple exploit to do require child process, or then run some other stuff that I want to do. Invoke a reverse shell, do whatever I want there, etc. So far I think about vulnerabilities in open source libraries. And as we kind of walk through this exercise of understanding how vulnerabilities are not just in our code, or also in open source vulnerabilities, we come to realize that attackers would no wonder try to gain access into open source and either through malicious packages or find and exploit those vulnerabilities because of the simple package economy, right? How many packages are on NPM and how many people are using them? So if an attacker is able to exploit something in MS, in Dust.js, in SD, in so many libraries that Lodash recently, etc., what would happen is one exploit in that would actually affect many victims. So it's a very economically good trade-off to try and do. To explain a bit more about why is it so challenging to actually address open source vulnerabilities in those libraries, as with something like Snyk or anything else, is understanding that package dependency is something that is kind of complicated. Because if you think about it, it's not just, like we said, not just a direct dependency, it's actually that nested dependency and then that nested dependency, etc. And what happens if you have a three levels deep nested dependency like we had in this app, the Goof app, HMS and then MS. And what happens if MS is vulnerable, which is the version that HMS is bringing in, and there's a fix for MS. But actually, there's no upgraded version, there's no released version of HMS to get that fix because the maintainer has gone, he's not active anymore, etc. You're going to get stuck with that vulnerability, and we need to figure out how to manage that. So this is parts like sneak patches that kind of helps you handle that, but it's a very not straightforward way of the challenges that are happening with package ecosystems. So this kind of shows how we find vulnerabilities. So as we kind of gather data through sneak users, like this is basically people that we just scan their package manifest and requirements, Python, JSON, whatever that is, and we put it on a bar, and we have plotted where do we find vulnerabilities. So where do we find direct vulnerabilities, and how often do we find indirect vulnerabilities? And as we're JavaScript, conference here, we're talking about NPM, which is the top right, the most right bar. You can see that in most of the time, 78% to be exact, we find vulnerabilities in indirect packages. That means even if you are a very responsible developer and you are, following all the change logs and security announcements of React or Angular or Vue or whatever, most of the time, we're not going to find vulnerabilities in those packages. Most of the times, as a fact, we're going to find it in those indirect dependencies. And this is why having, some tools, some way to help you manage those dependencies and the security around them is so important. So after all of this, right, what if security was easier? What if it was actionable? What if it was a bit more developer friendly? So like you wouldn't get a report at the end of the day of, this and that is vulnerable, but something that would be tied into your workflows. So for example, what if we were able to open pull requests to automatically relock your files, your package JSON, your yarn lock or package lock, whatever that is, upgrade to the most minimal version possible, right? So you want to upgrade to a minimal version just because if we change that, if we make an upgrade from 1 to 2 to have a security fix, that also means that you're going to get maybe a major breaking change in the API of that library. So it's important to actually make smart upgrades possible. And that's what actually is happening there with MS, right? It's a patch version which the maintainer was able to release as a security. And then if you have this the only thing that you have to do is, of course, make sure that all of your tests are passing, nothing has broken from updating a dependency that you have, and merge it in, right? And this is kind of what we're trying to gain into with DevSecOps is having, having all of your code coverage, having all of your Travis or Jenkins or SQL CI testing there, having something like Snyk, it can be anything else, can be Snyk as well, to have it and test your dependencies and check that someone is not adding a vulnerable dependency and block the build and not allow you to go forward until you address it. So I want to thank you for joining in today. I want to say, use open source, but stay secure. And if you want to ask any questions and talk to me, I'm going to be right here. So thank you very much.
Yeah, so basically don't trust anybody in open source. We have a couple of minutes. We can ask a few questions, if you would like.
All right, so no?
Guys need to think about it.
All right. I'm going to be here, so catch me and be really thrilled to talk to you. So
they need to start to check their open source packages.
For sure.
Thank you.
Thank you.